Okay, so now let's talk about some problems about the fundamental theorem of calculus part 1. And basically it says like into this, guys. If you have an, uh, in fact, guys, think about it this. This actually, if we only look at this piece, this stands for a function. Okay, this stands for a function. As we discussed, if ft is a positive function, and basically if this is f of t, this is start from a, this is x, and as you can see that, guys, with different value of x, this integral stands for the area and the curve between a to x, right? But again, since x is moving, so this integral actually stands for a function, which we also have a name for that function, which is capital F of x, right? And right, as you can see, which is also linked to this antiderivative function in section 4.8. And the fundamental theorem of calculus part 1 is said this: if you take the derivative of this function, and then that function is going to be f of x, basically, guys, you can see that all you need to do is to replace t with x here. So looks is very simple. However, you do have to be very careful about the part 1 fundamental theorem of calculus. Why? Because the integral is gonna be started from a constant to a term or to a variable, or maybe the variable is not only x, maybe a function of a variable x. Okay, and later on we're gonna see of them. So it start from a constant to a variable, or a variable involved function expression. And okay, so now let's look at the first problem. So I have this y equals integration from a to x t squared dt. They ask us to figure out what is dy dx. You can see that this problem is a direct application of this theorem, which we can easily write it out. It's going to give us is replace t with x, so it's x squared. Okay, easy to handle. Now, second one, look at this. Y equals x integral x to 7 t squared cosine t times dt. And you see, right now, the start index is x and index is 7. Here, if we try to use our fundamental theorem of calculus part 1, and you have to reorganize your integral expression. How? Well, this is what we can do. Right, this is the first property. Of the integral problem. And if we have this, and we can easily to apply that theorem. So dy dx is going to be negative times x squared times cosine x. Okay, so this is second problem, right? So it must start from a constant to a variable. Now let's look at the last one. Okay, y equals a integration from a to 1 plus 2x cubed t squared over t plus 2 dt. Well, different with the first two, as you can see that the upper index is 1 plus 2x cubed instead of x, right? We'll get used to x. But the idea is similar. What you can do here, guys, is remember when we discussed the chain rule, we introduced one intermediate variable u, right? Let u equals the inside function, and then we can do that. Very similar idea is to figure out this derivative. What I'll do is I'll also introduce one intermediate variable u. That, let's do this. Think about it this way. Set u equals 1 plus 2 x cubed. Okay. So do you agree that then the integral becomes a to u t squared over t plus 2 dt, right? This is our y here. And you see that, guys, for this pieces here, to get the dy dx, I'm actually gonna use the chain rule. So that is, I have to do dy du first, and then times du dx. Agree? Right? So how do we handle this dy du? Well, do you see that this is in the perfect format about fundamental theorem of calculus part 1. So dy du, which is u squared over u plus 2. Okay, and then times du dx. If we substitute u back, let's see what happens. We're gonna have it's 1 plus 2x cubed squared over 1 plus 2x cubed plus 2 times du dx, which gives us is 6x squared. Okay, and we can simplify this a little bit more. So it's 3 plus 2x cubed. Okay, so we finished this problem. Okay, and yeah, so let's just use the chain rule to handle this. Now, I would like to maybe use a very short to make a little summary here, friends. So let's see, guys. Given fx equals x squared, trying to figure out its antiderivative, we know it's x cubed over 3 plus constant, right? And I have at least two ways to describe this process. And remember that given this function, to find its antiderivative, it's called an integration process, right? So what I can describe is I can describe this, find this antiderivative as this indefinite integral process. Okay, this is gonna be x cubed over 3 plus c. Okay, also what I can do is I can denote this as a differential equation in terms of dy dx equals x squared. Ask you to figure out what y is. Okay, and y is a function of x, as you can see that. It's also this. And if you think about it, this guys, how do we handle this? The idea is very simple. If you integrate both sides with respect to x, and then left hand side you have an integration, you have the derivative. Those two are back and front and right and back direction. So those two are cancelled. Right hand side is just the integral of x squared dx, which is here. Okay. And if I don't know, so if I, let's see, put y of 0 equals pi, so this is gonna form a initial value problem. Okay, and this is the general solution only for this piece. Okay, only for this piece. With this initial condition involved, you can easily to figure out what c is, which c equals pi. So yx equals x cubed over 3 plus pi is called a particular solution for my initial value problem. Okay, so this is the main idea from 4.8. Well, let's also talk about this. Okay, this is what we call a definite interval, okay? And then what you do is you're going to use the fundamental theorem of calculus part 2. You find the antiderivative, and then you evaluate at those start index and end index, and they make a difference. So you have 2 cubed over 3 minus 1 cubed over 3. So you're going to have 7 over 3, okay? What it stands for is, you know, if this is a positive, it actually stands for the area under the curve from 1 to 2, okay? So that's the meaning. Also, we also define a function into this way, 1 to x. Well, in this problem, I cannot use x. I need to change another variable. Let's see, t squared dt here. This function is capital X, okay? And as you can see, guys, this actually is the antiderivative function, okay, of this x squared, okay? And the fundamental theorem of calculus part 1 is said that if you take the derivative of this capital Fx, and which basically is you take this, that result going to give you its Fx, which is x squared, okay? So right now everything linked together, right? So this is an expression for the antiderivative function, and then the derivative of that antiderivative function, which is calculated in this way, okay? So I'll stop here, and I'll see you next time.